So we've looked at how we solve first order separable differential equations. What I'm going to do here for you is I'm going to present you with a couple of examples for this. What I want you to do, pause the video, read the examples, have a crack at them and come back and check your answers with the working I'm going to present to you. Here you go. So I've got two questions here that I'm presenting to you. The first one, I want you to find the general solution of this differential equation, and then the second one is looking at finding the particular solution to the differential equation when I give you some initial conditions. So pause the video and have a crack at both of these. So the first one, find the general solution to the differential equation given here. Now for one of these questions, remember we have to separate it, so we've got everything involving a y on one side, everything involving an x on the other, and once we've done that, we can integrate it. Well, in order to do that, what I've got to do is essentially shift the dx up here to this side. We're going to multiply both sides by dx in order to do that. And what that means is the dx's here will cancel, and I've got my times dx on this side. So I can rewrite the equation as dy equals x squared plus e to the x dx. What I'm now doing is, since I've got my derivative dy on one side, my derivative dx on the other, and I know the variable upon which they depend, all I can do is quite simply say then that the integral of dy has to therefore equal the integral of x squared plus e to the x dx. Now I just calculate the integral of both sides and I've got my answer. So integral of dy, well, that's just simply equal to y. So I know y equals the integral of everything on this side. So integral of x squared, that's 1/3 x cubed, integral of e to the x plus e to the x. And I know I'm after the general solution, so I've got to remember my plus c. So remember, this gives you a family of solutions here, all of this format. I've not got any initial conditions or even conditions to substitute into here, so I can't find out which particular solution it wants me to find for this set of equations. However, this second question here wants a particular solution to this differential equation. So I am given some conditions here, y equals 1 when x equals 0 for this here. So what I've got to do is solve it to get the general equation and then use that with the conditions to get the particular solution. So again, same idea with this one, separate it so I've got my y dependence on one side, my x on the other, and I can integrate both sides. So if I do that and I rewrite it, I end up getting dy over y bracket y plus 1 equals dx. Everything with a y on one side, everything with an x on the other. Now, looking at this, part of me would think, great, I can use ln, I can use my logarithmic integration. However, the top power here isn't 1 less than the highest power on the bottom. If I multiply this bracket out, I get a y squared, which would mean that if I had a y on the top, something written with that format, I could then just integrate it using the rule of logarithm. However, I can't do that. So whenever you get one of this format, the first thing you need to think about is using partial fractions to separate this out. So if I were to do that, I'd have 1 over y bracket y plus 1 equals a over y plus b over y plus 1. I'm going to separate it out using that. Multiply through by y bracket y plus 1, and I get that 1 equals a bracket y plus 1 plus b times y. So now pick values for y, which I can substitute in and figure out the particulars of a and b. So if I choose, let's say y equal to 0, what I know is that I'm going to get 1, the b term here will disappear, it's going to be a times 0 plus 1, so a times 1, so 1 is equal to a. So I know the value for a from that. I can pick any value I want for y to get the b. I'm going to go with y equals negative 1 purely because it'll eliminate this term here. So if I go for y equal to negative 1, I'll end up getting that negative b is equal to 1, so rewrite it that b is equal to negative 1 here. What I now can do then is separate this side out here. Now I know the whole thing is going to be that the integral of this side equals the integral of that side, so I'm going to separate it into two fractions and calculate the integral of each fraction as a set term. So I'm going to rewrite this as therefore it's the integral of dy over y, take away the integral of dy over y plus 1 equals the integral of dx. So now that I've got that, I can integrate both sides. Well, integral of this side, that gives me ln y, take away ln of y plus 1 equals x plus c. Now, quick point, at this one, I've got two separate logarithmic terms here on the left. What to do before we find the particular solution by substituting in is rewrite it so we get everything that's got a y term together, and eventually we end up with y equals something dependent upon x plus c. Then substitute in our initial conditions to get the answer we want. So I'm going to combine these two using the rules of logarithms, and I'll end up getting ln of y over y plus 1 equals x plus c. If I then take the ln across this side, I'll end up with y over y plus 1 equals e to the x plus c. Now what I'm going to do is split this up here and write it as e to the x times e to the c. Now e to the c is just a constant. Again, we don't know the value of that constant yet. So what I can do is rewrite that as just k e to the x. So I've got y over y plus 1 equals k e to the x. I'm going to get rid of the y plus 1 on the bottom and multiply here by it. So let's take this up here and rewrite it. And I'll end up with y equals k e to the xy plus k e to the x. Stick the y across here, so I've got everything with the y in it on one side. And I'll get y minus k e to the x y equals k e to the x. Take y out as a common factor. I'll get y bracket 1 minus k e to the x equals k e to the x. And then substitute this across, take this across. And what I'll end up getting is that y equals k e to the x over 1 minus k e to the x. Now that I'm at this point, I'm going to substitute in my initial conditions. So I'm going to substitute in the fact that initially, the condition I'm going to be given is that y equals 1 when x equals 0. So if I put those in there, what I'll end up getting is that 1 equals k times e to the 0. So k times e to the 0 over 1 minus k times e to the 0. So k times e to the 0 is just going to be k, because e to the 0 is going to be 1. Anything to the power of 1 is 0. So now I've got to solve that. Take this across and up. I'll get 1 minus k is equal to k. So that'll give me 2k equals 1. So k equals a half. Now I can take that back and substitute it into here. What I'll end up getting is that y equals a half e to the x over 1 minus a half e to the x. I can get rid of these halves here. What I'll end up doing is I can rewrite that then as e to the x over 2 minus e to the x. So there you go. I've got the particular solution given those conditions at the start. If I were given a different value of y for a different value of x, I could work it through and I'd get a different family of functions which satisfy those conditions that were given. But for this one, there's your particular solution there. Y equals e to the x over 2 minus e to the x. Remember these steps whenever you're substituting and solving for the particular solution. Get it written as y equals, then put in the values. Make it as easy as you can for yourself so that you don't have to do too much jiggery-pokery on working about with it, and you'll just get your answer quickly, easily, and effectively.